Hola, buenos días. Es un placer hoy presentar a Amdjed Dali, que es un arquitecto restaurador con una amplia experiencia internacional, digamos, en la restauración, especialmente en la restauración de arquitectura de tierra. Y nos viene a hablar de la arquitectura de tierra, las técnicas constructivas en una región muy peculiar de Argelia titulada Ziban, y todos los análisis que ha hecho para su conservación y su puesta en valor. Os dejamos con el que lo disfrutéis. Saludos.
Good morning, everyone. My name is Amdjed Dali. I'm a conservation architect, professional trainer, and researcher working on Earthen architecture and heritage conservation. And today, I will present a study titled Earthen Architecture and Construction Techniques in the region of Ziban in Algeria, case of the Ksour of Chetma and Lichana. So before I begin, I would like to thank the organizers of this UNESCO Chair Conference, and special thank to Eva Tortajada for the invitation and the opportunity to chair this work or this research. So this research look at how traditional earthen construction shaped the architecture of the Ziban region, a place with a strong cultural history and unique desert environment. And by studying the Ksour of Chetma and the Ksour of Lichana, the work shows how local materials, building skills, and spatial organization respond to the climate and continue long-standing traditions. So let's begin with the broader context, earthen architecture in the Saharan world. So earthen architecture shows close relationship between people and their land. It uses local soil to build houses and spaces that fit the climate, the weather, the culture, and daily life. In the 20th century, architects like Le Corbusier in France, Hassan Fethi in Egypt, and groups like Khater in Grenoble, France, helped bring attention back to the earth as a useful and modern material. So in Algeria, a country located in North Africa, earth has been used for building for many centuries. But in the last decades, these traditional techniques started to fade as concrete or cement concrete and industrial materials become more common. So basically, we can say that Algeria is a desert, and more than 80% of the country is part of the Sahara, and the weather is very hot, very dry, and often windy. So we're talking about the 80% of the territory. So the Ksour show how people adapted to this harsh environment, and these settlements are built with earth, stone, palm wood, and this creates thick, strong walls, cooler interior, and buildings that blend naturally with the desert. So we already have some research on how the settlements work and how they perform in the desert climate, but there is still little information on how these buildings were made and how the earth was prepared and how the materials were mixed and how the walls were built. So this study I'm presenting today focuses on that missing part. So now let's look at what Ksour are, where they come from, and how they evolved over time, of course. So the Ksour, it's an Arabic word, and it's the plural of Ksour. They are fortified settlements found across the Sahara. You can find them in Mauritania, Mali, Algeria, of course, Tunisia, Libya, Morocco, and the Western Sahara. And they are more than all settlements. They are smart designs made to survive the desert. And unlike Medina, Ksour are built in open desert. They are organized for community life and for protection. And even though they can look different, Ksour share common features. So they have central sacred place, separate public and private area, and layout for defense. So the photos I'm showing on these slides show the Ksour of Timasin in Algeria. And the next slide shows the Ksour of Ghadames in Libya, and both examples give clear idea how the settlements look and work. So next we will see how Ksour developed over time. So Ksour have very old roots. They appeared along trade routes connecting North Africa with the Sahel and the Mediterranean. And with the arrival of the Islam, the religion, the Ksour architecture changed. People moved from semi-nomadic camps to permanent settlements. They were often built on higher ground near the water, like the example I'm showing now in this slide, Ait Ben Haddo in Morocco. Very nice example. I had the opportunity to visit this place 13 years ago. So their layouts, sometimes in grids, sometimes in circles, always followed the land, helped with the defense, and made use of water sources. Now that we know their origins, let's see how Ksour influenced life in oases. So the Ksour are closely linked to oases. Together with palm groves and water channels, they create self-sufficient systems. So the Ksour is the social and spatial center. It organizes farming, homes, and daily life around the limited water available. Study made by Nada Miluka a year ago in the Ksour of Wergla in Algeria shows how the settlements balance the environment and religion and survival. So next we will see or we will focus on the specific region of this study, which is the Ziban. So the Ziban region is located in northeastern Algeria, situated between the Oras Mountains and the Sahara Desert. It has three zones: northern one, which is highlighted in red in this figure, as you can see. And we have also the southern region highlighted in green. And finally, the eastern Zab, which is in blue in the figure. So each with Ksour and oasis settlements like Tolga, Lichana, Liwa, and Sidi Oqba, and of course other settlements. So these settlements were built inside palm groves and the long wadi linking houses, farm, and water systems. So the region faces major environmental challenges, especially floods, and the worst one happened in 1969, 50 or 60 years ago, causing heavy damage in Biskra and its oasis. And this changed the way water and planning were managed, and many people left the Ksour leaving some empty. So now that we understand the region, let's look at our two case studies. So the study focused on two Ksour, the Lichana one in northern Zab and Chetma in eastern Zab. So both have been studied since 2014 through academic, professional, and volunteer projects, and I have participated in most of them. And during all this time, I collected technical and historical data that helped me to understand how these Ksour were built. So these sites also they show that heritage can support sustainable development in the Ziban region. So despite their architectural and cultural value, we know very little about the construction techniques and materials used in Chetma and Lichana. So the condition of the two Ksour is very poor, Some buildings are completely collapsed, and many others are partially damaged, making it urgent to study them. And you can see from this drone photo how is the condition of the Lichana Ksour. So this study aimed to characterize, diagnostic, and compare their materials through in situ tests to understand composition, cohesion, and additives like wheat straw. So the goal is both scientific and practical, to document traditional know-how and provides data for future conservation work. So the following section outlines the methodology applied in this research, of course. So the methodology combines architectural fieldwork with material science. We focus on Ksour, Chetma, and Lichana to understand how local materials and building know-how respond to the Saharan environment. So the process started with on-site in situ surveys, recording construction techniques, and this start 12 years ago. 11 years ago. So I have recorded construction techniques, decay forms, and sampling representative materials. So these samples that I took a year ago, they underwent in situ tests like sedimentation, Seeger, and pellet tests to identify soil composition and additives. So finally, we compared the results between the Ksour, linking material properties to geography, environment, and building logic. So this approach bridges heritage documentation with practical data that can directly inform restoration and sustainable construction practices. First, let's look at the wall system in Lichana. So they used an English bond pattern, as you can see in the figures, coated with earth plaster, and most of them today are collapsed or not collapsed, eroded. So you can find the erosion of plaster everywhere in this Ksour. So the walls are with or without stone bases, and sometimes reused from ancient Roman ruins that enhance stability and moisture resistance. And unfortunately, most of the Ksour is now damaged, with the walls affected by erosion, plaster loss, and damp problem. And regarding the roofs, they are built using palm trunks as beams, as you can see. But the mosque, however, shows French colonial influence with IPA joists and hollow fired bricks filled with between them. So, despite this, the traditional character is preserved thanks to what we call TWISA, collective system construction and maintenance, that has passed skills down through generations. So now we will examine the construction techniques in Chetma. So Chetma follows the same logic as Lichana, with earthen walls, adobe earthen walls, of course with or without stone bases, and earth plaster. So however, it is in worse condition than Lichana. Erosion, rising damp, and wall collapses are widespread. So in 1969, floods and many years of neglect and abandonance have accelerated this decay. The roofs were originally made from palm trunks and branches, which helped with thermal control, and today most of them have disappeared due to the humidity and decay. But especially a failed restoration attempt about 20 years ago made the damage worse. Immediate stabilization is needed to preserve what remains. So let's now go to the material analysis. So basically we have collected 6 representative samples, and in this presentation I'm showing only 2. So one from Lichana near the western gate, as you can see, and one from Chetma between the two mosques. Both bricks have similar sizes, 40 by 20 by 10. However, it is possible to find mud bricks 36 or 37 centimeter long. And each sample was crushed and divided for different in situ tests. So Lichana soil is sandy loam with 65% of sand, 22% of silt, and 13% of clay. And the Cigar test measured 11.7 centimeter, and the palette broke easily, showing moderate cohesion and low plasticity. So the soil is easy to work with, but weak against erosion unless reinforced with additives. So, in the other hand, Chetma soil has similar proportions: 67% sand, 18% of silt, and 16% of clay. But it performed better mechanically because the longer Cigar test and tougher palette show stronger cohesion because helped with the addition of wheat straw. So the straw acts, the straw is of course fiber, and it acts as a bridge across microcracks, improving ductility and resistance to shrinkage and erosion. And this shows how Chetma builders improved the material with organic reinforcement, something that is missing in the Ksour of Lichana. So in summary, both Ksour use almost the same systems: sun-dried mud bricks with or without stone bases, and palm wood structure. They are well adapted to the climate with thick walls for insulation and compact layouts to resist heat and wind. But earth buildings are fragile, and without regular upkeep, they erode and eventually collapse. In the past, people replastered and repaired building after every rainy season. When this stopped, when these activities or this event stopped, decay accelerated, and this is very problematic. So what we see today is both physical and cultural erosion, the loss of knowledge and traditional maintenance practices, and this is very problematic for Earthen construction or Earthen heritage. So how we can respond? And this is a very good question and very important one. So preserve the authenticity of the material, understand the earth before any intervention. In Chetma, for example, use the clay rich soil with straw, and for Lichana, focus on protecting surfaces from erosion. It's important that the new restoration material are compatible with the old ones, and I will say it again because it's very important to say and to know that the new restoration materials should be compatible with the old ones. So the conservation should also revive the traditional maintenance culture, train local teams, teach repair skills, and restore the habit of regular care. So before the COVID in 2019, we have organized many workshops and workshops in Lichana to help locals maintain the Ksour, but unfortunately this activity stopped during the pandemic, and we have not been able to restart them. It's for now it's very, very difficult. Anyway, now let's conclude with the key points. So this comparative study shows that both Ksour have sandy loam base, but the addition of straw in Chetma improves material performance. Lichana soil is less cohesive and needs more protection. On-site testing proved very useful when lab access is limited. It provides direct understanding of the material and guides conservation work more precisely. So, looking ahead, conservation should combine technical and social approaches, using traditional materials and reviving especially traditional knowledge. Restoring Ksour is not just about rebuilding walls or conservation walls, it's about conservation the culture that has supported them for centuries. So, building on this approach, my current research examines the colonial heritage of Biskra with a focus on hotel architecture and the influence of local building traditions on their design and construction. So I plan to publish this new scientific work or article in the coming month, I hope. So this brings the presentation to the end. So thank you for your attention, and I hope this presentation has shown the architectural, technical, and cultural significance of the Ksour of Chetma and Lichana, and the importance of preserving the knowledge and traditions that sustain them. So I leave you my email in this presentation. You can see it down in the screen. Here, right here. So again, thank you and goodbye.